Hey guys, thanks for watching this. I just want to show you this last example, number 5, that we didn't get to in class. Take a moment to write it down, please. Number 6 and number 7, we didn't get to. I'm not worried about those. I'm just going to cut those from our quiz and tests and stuff like that. Don't worry about 6 and 7. But let's take a look at this number 5 here. So in this one, I would say that the left side is harder. Noticing that this is a subtraction problem with fractions, I'm thinking I'm going to do a common denominator. And one thing I always taught my kids in Algebra 2 when it was subtraction is I would always force them to make it a plus negative. That's because this negative with the 2 is going to have to get distributed. And if you leave it over here as a minus, you often forget that it's there. Cool? So I'm going to make it a plus in the middle. Set up my 2 fractions. And let's find a common denominator. So this fraction has 1 plus sign. This one has 1 minus sign. Those are not the same thing, so we're going to need one of each in our denominator, in our common denominator. 1 plus sine x and 1 minus sine x. We're going to need them both. Notice I'm using parentheses. That notation is really important. Your math work has to be accurate here. All right, let's take a look at this first fraction. So he already had the 1 plus sign in the denominator. What's he missing? 1 minus sign. That's what I'm going to multiply by here, 1 minus sign. I would probably parenthesize that to remind yourself that this 2 is going to get distributed to both of those. So you're going to have 2 minus 2 sine x. Similar idea over here. Remember, you can always pause or fast forward or rewatch anything here that you need. All right, this fraction already has 1 minus sine x, so he's got this piece. He's missing the 1 plus sine x piece. So he needs to multiply by 1 plus sine. Parenthesize him. That's going to remind you to distribute here. And again, that 2 is a negative because I made it a plus negative. So that negative 2 gets distributed. All right, resist the temptation to try to cancel stuff out. Okay, top and bottom you don't want to cancel because that's going to undo your common denominator work. You also cannot simplify diagonally, cross cancel. You can't do that because it's adding in the middle. Cross canceling only works when it's multiplying in the middle. So instead, what do? We put them together as one big fraction. That was our point of doing a common denominator, was so that we could put them together as one fraction. So you're going to have this plus this all along the top. All right, from here, what can we simplify? What do we see? Hopefully you see on the top, look, there's a 2 and a negative 2. Combine those like terms, they cancel out. You can also combine negative 2 sine x and negative 2 sine x. Those do not cancel. Those would combine to be negative 4 sine x. And actually, I just peeked at my problem looking at my answer here. Look, I need a negative 4 in my answer. There's that negative 4. See, it's starting to come already together. All right. Now, in the bottom here, in the last problem that we did, number 4, we also had to do a common denominator. Let me go back and show it. Here it is. We did a common denominator here, and we left the common denominator we left it factored. We didn't distribute in that cosine because it ended up canceling out later. In this one, we actually are going to go ahead and put these guys together. We are going to multiply or FOIL those 2 guys together. All right, if you need to do the work off to the side, please do. We're going to do 1 times 1, 1 times negative sine, sine times 1, and then sine x times negative sine x positive times a negative should be a negative sine squared x. Kind of ran out of room there. I hope that's okay. I wrote it underneath. That's all right. Okay. Simplify this. Combine your like terms. You should see here in the middle. These guys do combine, and they actually cancel. One's positive, one's negative. So that denominator is going to be 1 minus sine squared x. Maybe some of you noticed that that was going to be 1 minus sine squared without doing the foiling steps. Maybe you noticed that this was a difference of squares here, this factored version. So maybe you could put it back together more quickly without doing the full FOIL. If you see that, that works as well. All right, let's see. What should I do from here? I've got a squared, but I'm looking at my answer. I don't have anything squared in my answer. I have a secant. What is secant? Secant's 1 over cosine, right? And tangent is sine over cosine. So I need some cosines in the bottom. I don't even have a cosine in the problem. What could I do? What if I used my favorite Pythagorean identities? 1 minus sine squared, that is a Pythagorean identity. That is cosine squared. Straight off your Pythagorean identity sheet. Or your pop quiz or your notes, whatever you're looking at. Cool? All right. We're almost done. We're almost done. All we have to do from here is a little bit of manipulating, a little bit of magical work here. So notice I even wrote down this secant was 1 over cosine and tangent was sine over cosine. That kind of helps my brain think that I need 2 of these cosines in the bottom, right? Like cosine squared in the bottom. So think about this cosine squared. What that really means is, let me rewrite it. What if I change cosine squared to mean cosine x times cosine x? Because that's what cosine squared is, right? I'm going to bring the top over. Now we're just going to kind of fudge it a little bit here. Let's take a look. So our answer needs, I'm going to highlight, how about this? We need a -4 in my answer. Add a -4, it's on the top, that's good. We don't want it as a fraction. We need a secant, which is 1 over cosine. So we need a cosine in the bottom. And then we need a tangent, which is sine over cosine. Oh, well, I have a sine over cosine. Do you see how I have all of the pieces I need? I just have to rewrite it in a different way. Okay, I've got the -4. I've got a cosine in the bottom, which is the same as secant, or secant x. I always forget to say the x, sorry. And then I've got a sine over cosine, which is a tangent x. And that is what I needed. I need my smiley face. Maybe an extra yay math. All right, great job, guys. I hope that helped and made sense. Make sure you try the homework. I know it's gonna be hard. You're not supposed to be able to just look at it and see it. You're supposed to stumble. You're supposed to struggle. You're supposed to fight through it. All right, so try something, put pencil to paper, see where it takes you. I am after school today, which is the 11th. Next week, I'll be after school on Tuesday the 16th and Thursday the 18th. We've got a test coming up on the 25th, I think. So let me know how I can help. Sorry I'm not available on Mondays. Too many meetings and trainings and SOLs, but let me know how I can help. Good luck, guys.